Assalamualaikum and good morning. Today our group are going to present about hybrid photovoltaic, PV and wind energy impact on load flow. For the abstract, photovoltaic or PV system have become one of the main catalysts in power generation. From year to year, the demand for electricity increases while non-renewable energy sources decrease. Therefore, it is significant for authorities such as engineers to revolutionize the energy landscape with renewable properties. Everyone must know this is fundamental, especially in preserving nature and reducing pollution. The use of PV system in the power grid is becoming increasingly widely accepted by all factories and the public. This system must operate well to produce optimal, efficient, and reliable power. For the introduction, the integration of photovoltaic or PV systems in power system has gained importance due to the increasing demand for renewable energy source and the need for the decarbonizations. PV system provide a clean and sustainable energy solution by converting sunlight directly into electricity. However, the intermittent nature of PV generations influenced by solar irradiation and temperature, it poses challenge to the steady state stability of power system. The integration and management of PV system require an understanding of the stability implications. Steady state stability analysis focus on evaluating the long-term behavior of the power system to ensure it operates within safe limits under steady state conditions. These include maintaining constant voltage levels, frequency control, and power balance as PV generation fluctuates. Unlike traditional power plant with predictable and controllable outputs, PV generation is subject to variation due to the weather patterns and daylight availability. These fluctuations can lead to voltage variations, frequency deviations, and reactive power imbalance potential, causing instability or system-wide failure if not properly managed.
The main problem in renewable energy system is the variation in power generation from time to time due to the intermittent nature of the renewable source. Mismatching between power generation and load power causes a deviation from the desired voltage and frequency in power supply. A power flow control of photovoltaic wine battery hybrid renewable energy system HRES for standalone application is presented here to balance the power generation and load power. A control strategy is implemented with fuzzy logic controller for smoothing of the power fluctuation and at the same time to maintain the battery state of charge SOC within allowable limits. The various components are modeled and simulated in MATLAB or Simulink. Simulation study is done at changing nature of power generation and load demand with an initial battery SOC. The result obtained show that in spite of sudden load change and change in the power generation, the power balance between the supply and demand effectively maintained by the proposed fuzzy logic-based controller FLC. The power fluctuation is superpressed and supply a good quality power while maintaining SOC within limits.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aqwa Nabila binti Muhammad Fazil. My matrix number is DE220049. Today, I would like to talk about the conclusion from the literature review, which is the title A Hybrid Renewable Energy System Integrating Photovoltaic Panels, Wind Turbine and Battery Energies for Supplying a Grid-Connected Residential Load. In this paper, a topology of a multi-input renewable energy system including a photovoltaic system, a wind turbine generator and a battery for supplying a grid-connected load is presented. The system utilizes a multi-winding transformer to integrate the renewable energies and transfer it to the load or battery. The PV wind turbine and battery are linked to the transformer through a full bridge DC to AC converter, and their energy supplied to a grid-connected single-phase inverter and loads. A phase shift control technique is employed to the control and the power flow between the source and the load to the grid. To control the power flow, simple PI controllers have been used. The operation details and the control technique of the system are presented and also validated by using numerical simulations.
Hi, my name is Muhammad Ashraf. So today I will present on methodology of our project. In project management, a flow of work is required to visual at understanding the methodology. In order to understand the current state of research on power system stability with renewable energy integration, which is we focus on hybrid solar PV and wind generation. Our team are required to study on IEE 30 bus system, which means we conducting a literature review. Next, we analyze the suitable simulation. We use the Newton-Raphson technique is used to solving the solution of the nonlinear equation, and then we simulate it on MATLAB software. Next, we move to performing load flow analysis. For this step, we have choose bus 7 and 10 to be modified as we use the renewable energy integration. The take original value of the bus before modification is P and Q value are required. Afterward, the load was increased to 100% and the voltage reading at bus 7 and 10 were recorded. Next, we conclude the data analysis on hybrid PV and wind generator bus data. So as the result, we can do judgment on stability of power system IEE 30 bus with hybrid solar PV and wind generator, which increase in load until the system collapse. And thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqmanur Hakim bin Muhammad Arifin. My number matric is DE220205. So to complete this project, we have choose the IEE bus 30 system that we have modified with the integration of the hybrid PV and also wind energy. As you can see here from the slide, we put the turbine wind energy at the bus 10 as a additional generator, and also we have put the hybrid PV at the bus 7 to calculate the impact of the renewable energy into the grid system, which is IEE bus 30. So we will go next for the simulation. So this is the simulation result. So for the simulation, we actually do the two simulation, which is the first one without the renewable energy integration, which is hybrid PV and also solar wind, and the next simulation, which is we have to do the load increment with the new integration of generator. So as we can see here, this is the input coding after doing the power injection from hybrid PV and wind energy at each at the bus, which is bus 7 and also bus 10. from this coding, we will get the steady state stability analysis. As you can see here, the power generator for hybrid PV we choose for 50 megawatt, and also for the wind energy is 40 megawatt. So from here, you can calculate the load voltage PU, and also do the evaluation, and also we will know the steady state stability analysis from the simulation. We'll go to the next discussion. So for the integration of the solar PV, the total increment of the load that we can do is actually at the 182.4 megawatt active power, and also 87.2 megawatt for reactive power. It's the increment of the load that we can do is about 200%. This is because in this simulation we have changed the load of the bus data. We time by 2, it will get 100% increment. So for the PV solar, we have reached the 200% at the bus 7, which is after the next increment, we get the collapse data, which is it's below the range of that we have been set, which is from zero point 0.9 to 1.1 pu. So we will go next. So right now I will explain about the discussion. On here the discussion, we have done the comparison, the voltage PU between the hybrid PV and also wind energy. Before the power injecting at the bus 7 and bus 10, we will get the maximum of the load increment without the renewable energy integration is at 182 real power, and 182.4 megawatt for the real power, and also 87.2 MVA for the reactive power. After then, the bus 7 and 10 are 100% increase in the load until the system collapse. So here is the before injecting, and next I will explain about the after injecting. So here is the value after power injecting at the bus 7 and also bus 10, which is for the bus 7 we use the solar PV, and also for the bus 10 we use the wind turbine. So as you can see here, after doing the simulation, with the renewable energy resources integration, we can see the result is the voltage PU for both energy have different increment. For solar PV, the total increment at the load before its collapse at 182.4 megawatt, and also 87.2 MVA is actually at 200% of load increment. But for the wind turbine, we can see it's collapsed till 46.4 megawatt, and also 16 MVA, which is in 300% of load increment. As we can see here, for the wind turbine, it can accommodate more voltage PU than solar PV. But instead, the value for the real power and also active power for solar PV and wind turbine is different, which is as we can see, the solar PV can accommodate the more real power and also active power from this simulation. So as a result, the voltage per unit or load voltage PU will drop as the load grow. The maximum load power that can be accommodated by the hybrid PV is 91.2 megawatt and also 43.6 MVA. For the wind energy, 46.4 megawatt and also 16 megawatt with an additional integration like hybrid PV and wind energy, it will impact the unit value PU in each injector bus. If there are new resources getting into new bus system, the load increment can be done into 200% for hybrid PV and wind energy about 300%. The unit value becomes slightly higher due to the new integration. The per unit value before the renewable energy in both of the buses is 0.2921 for bus 7 and also 0.937 in bus 10. After the injection, it became 0.955 and 0.960, which is it will give us a benefit, which is the load distribution of load across the grid can become more balanced while it localized generation, reducing voltage drops and also increasing voltage level. So there are some factor about this simulation, which is we can consider some of the like the location of the this experiment doing, which is different places have a different sun irradiance. As example, for the solar PV and also the wind speed is also different. So we can take all the location factor and also geometrical factor for giving us the accurately data. So I think that's all from me. And also for the steady state stability, we can get the we as from the result we can see that the steady state stability for the after including the new integration of renewable energy is actually stable. So I think that's all from me. Thank you.
Finally, for conclusions, integrating photovoltaic systems offer the potential for sustainable energy generation, environmental preservation, and energy independence. Despite existing challenge, technological advancement, supportive policies, and market dynamic provide opportunities for accelerated photovoltaic integration. Continued research, innovation, and collaboration across various sectors are essential to realizing the full benefit of photovoltaic system integration and accelerating the transition to a clean energy future. Looking ahead, the future of PV integration is promising. Perovskite solar cells and tandem solar cells also was an improvement in photovoltaic technologies with great potential for enhancing efficiency and reducing manufacturing costs. I think that's all from our team. Thank you.